in order to use our property, we have to have a single base on each side. So when I have these 5s multiplied together, how do I put those together? Well, kind of. If it were 5 times 5, it would be 5 squared. If I said like x squared times x to the 4th, what does that become? So if these are multiplied, what do I do with the exponents? Add them. So this becomes 5 to the 3x minus 2, if we combine like terms. Now we have to get the same base on each side.
So we don't multiply our 5s?
Just like here, when you multiplied, it stayed as x. You just added the exponents.
Okay.
So right here, we have that x plus 4, but my base is 1/5. In order to use our property, I need my base to be 5. What can we change 1/5 to? 5 to the negative 1. Okay, we can't drop the base until it's just 5 to a power on each side. With these exponents, power to a power, what do you do with those? Multiply. So this becomes 5 to the negative x minus 4 power. Now my 5 is written once on each side, so we can drop it and just set the exponents equal. So if I add over my x, add over my 2, divide by 4, and we get negative 1/2. And we did talk about how you could always check these just by plugging them back into the original. Is that one okay? Let's practice some more, please. So I have to get the same base on each side. Can I change 3? No, so it stays. How would I rewrite 27? And you keep that 2x on the outside. So then, a power to a power, what do we do with those? So now we have the base of 3 on each side, so x squared minus 7 equals 6x. Subtract over my 6x. All right, now what? Factors. What multiplies to negative 7 and adds to negative 6? The x to be 7 and negative 1. These problems, all of your answers should work. If your math is correct, you don't get extra answers. Do you guys think you can try one over one? Why don't you do this one? X, so I can't multiply these. But I could change 4 to what? 2 squared. What can we change 16 to? So that gives me 2 to the 2x times 2 to the x squared equals 2 to the 8th. Now, we can multiply these because the bases are the same. That means you add the exponents. So 2 to the x squared plus 2x power equals 2 to the 8. So everything had to be the same base first. Now we use our exponent rules. Power to a power will multiply. When the base is the same, you add the exponents. Then we use our property that says we can drop the base. So x squared plus 2x minus 8 equals 0. What multiplies to negative 8 and adds to positive 2? So we get negative 4 and 2. Let's try another one. Try that one. Exponent rules. Think about when you change floors, that changes the negative. So if I want to bring this back up to the top, that would have to be a negative 2 power. E to the negative 2 means 1 over e squared. And so then, these are multiplied together, so we add the exponents, so we get e to the 3x minus 2. So now you just have e to a power on each side, so you can drop that. It's a quadratic, so I want everything on the same side. So x squared minus 3x plus 2. What multiplies to 2 and adds to negative 3? So if we set those to 0, we get 1 and 2. Let's do another one. The cube root of 5 to the negative x power equals 1/5 to the x plus 2 power. Our goal is to get the same base on each side. What can we turn both the cube root of x and 1/5 into? 5. Okay. We aren't changing the problem. We are just rewriting it. A cube root is the same as what power? Okay. 1/5. If I want to write that as 5, what kind of exponent would bring that back up? We multiply our exponents. We get 5 to the negative 1/3 x equals 5 to the negative x minus 2. Now you have 5 to a power on each side. So you just set the exponents equal. We add over our x, negative 1/3 plus 1, 2/3. So you divide by 2/3 or multiply by 3/2. And get negative 3. Okay, so you have to use exponent rules to get it to a single number to a power on each side. I'm going to do one final problem of this. 3 to the x cubed equals 9 to the x. What's my common base going to be? how would I rewrite 9? So 3 to the x cubed equals 3 to the 2x. So x cubed is equal to 2x. I can subtract over my 2x. What would I need to do to factor that? So if you set those to 0, you get x is 0. Here, to get rid of square root without plus and minus, so plus and minus square root of 2. So sometimes we just get a single answer, sometimes we have multiple answers. All right. Any questions on that? Sometimes you are asked to solve problems where the variable is in the base. So I'm just going to do a couple of those. We won't have very many of them, but just make sure we're okay with that before I do anything else. So if I said b to the 5/2 power equals 243, how would you rewrite a 5/2 power? What does that mean? Okay. We can either get rid of the 5th power or the square root first. It does not matter. Which one do you want to get rid of? Okay, opposite of a square root is? I'm going to square both sides. So I get b to the 5th equals 59,049. How do you get rid of a 5th power? Do you need plus or minus? No, only if it's an even root. So then we get b equals, the 5th root of 59,049 is 9. Okay. B, how would I write this one? Okay, you can decide. Do you want to get rid of the 4th power or the cube root first? So to get rid of the cube root, we cube each side. H to the 4th equals okay, how do you get rid of a 4th power? Do I need plus or minus on that one? Yes, because it's an even root. So I get h to be positive or negative 27. So just make sure if you add an even root, you need a plus and minus with it. Do we have any questions? Okay, so there are 2 things that we're going to do today. This is the end of what your homework is. So I want to give you some time to work on your homework. I also want to do a little bit about the last topic in this section, but I'm not going to give you homework over that yet. So would you rather work for 15 minutes and then me teach the last bit, or do you want me to teach for 15 more minutes and then work on homework at the end? Work first? Okay. So I will let you work for about 15 minutes on this handout. It's due tomorrow. So I just want to look at calculating interest because it uses some exponential functions. And interest is a fairly common thing you're going to encounter in your life. First of all, when you're talking about interest, you'll have different payment periods, and we need to make sure we know what these things mean. What does it mean if it says you get paid annually? Okay. Annually is once per year. What's semi-annually? What would quarterly be? Monthly? So once a month, so that would be 12 times per year. And the one that you'd be surprised how many people don't know, how many days are in a year? All right, so when we're working these problems, we'll see these terms. That's how often interest gets paid to you. So what that means, if you get paid interest monthly, that means they take the amount in your account at the end of the month, they calculate the interest, they add that to the account. So the next month, would you get the same amount of interest? No, because you have more money in your account, right? They added that interest to it, so you get paid interest on that larger amount each time. This goes up, so the more often you're compounding, the higher your amount is going to be. You know, if I get paid interest daily, then my amount is going to grow faster. This could get higher than daily. You could be paid every hourly or every minute or every second, and that leads into what's called continuous compounding. So we're looking at two forms of finding interest. Compound interest. I won't make you memorize the formulas, but I'm not going to tell you what they stand for. So on any problem on a test or quiz involving these, I would give you the formulas. You have to know what the variables mean. So A is your ending amount, sometimes called future value. T is time in years. P is your principal or your starting amount, or sometimes called present value. R is your rate. Your rate always has to be in decimal form. And N is how many times we're compounding per year. Now, if we get paid interest constantly, then we can't have an N value, and so that has a separate formula. So continuous compounding is A equals PE to the RT. E is a button on our calculator. The A, P, R, and T are the same as in the previous one, so we just don't have N in this scenario. So we're just going to practice using these. We'll do a few examples today. Tomorrow we won't be in here very long, but we'll have a little bit of time, and we'll finish up then. So if I asked you to find the future value of $100 invested at 4% compounded quarterly after a period of 13 quarters. In general, I think it's really hard to read the problem and know what to do, so I like to write down. Find the future value. What's future value?
A.
So my A is what I'm looking for. So what do you think 100 represents? Present value. That's what I have right now. Invested at 4%. Your percent is your rate. If I move 4% into decimal form, that would be compounded quarterly. N is the number of times we compound in 1 year. So quarterly would be 4. And my time. We have to pay a little more attention. 13 quarters. Time has to be measured in years. So how would I turn 13 quarters into years?
3 1/4 years.
You divide it by 4 because 4 quarters in a year. So we get 3.25. All right, so I like to make a list of my variables. We are compounding, so our just regular compound interest formula, which you don't have to memorize. And we're just plugging in. So I don't know A, P is 100, R 0.04 divided by N, which is 4 times 3.25 power. So I just plug each variable into my formula. Did you guys all get that? I recommend just plugging this entire expression into your calculator at once. And I would like everyone to try it so you can make sure you're getting the right answer when you plug it in. A is an ending amount. It would be a dollar amount, so we do 2 decimal places here. And what did we get? Oh, thank you. All right. That's what part A asks for, the future values. Part B is the amount of interest we've earned. How do I find out how much interest? This is how much I ended with. How much did we start with? So you just take your ending amount minus your starting amount, and we get that we were paid $13.81 interest. Bless you.
She explains it way better than this, you know.
Oh no.
It was freaking me out.
It shouldn't be that bad.
No, when he explained it last year.
Oh, okay, I got it now.
As soon as I saw
Good.
the equation, I was like,
All right, can we try another one? Okay, find what investing $1,000, so that's what I have right now. What variable is that? P. An annual rate of 10%, what's that? R is 0.10. Compounded continuously. As soon as you see that word continuously, what does that tell you? There's no end. We are using the continuous formula. Would yield in 3 years. So 3 is my T.
bro, I'm never to talk ever again. That's such a lie.
So we plug those in. We know P, R, and T.
Did she just say? Wait, so you just work the E that you press?
There's 2 different places. If you look like above the on button, 2 buttons up, there's the LN, and above that in blue it has EVX. So if you hit second LN, that will break it up.
Okay, that works. What do you have to do? Put the multiple. Pause.
Mhm.
Ah, hi. Yeah, he was never teaching us that. He must not like you very much. I don't know, he just confused me.
So did you guys get $1,349.86?
Yeah.
Okay.
God, I'm good at that.
So far, so good? Is anyone having trouble finding E on the calculator?
I just don't think I'm putting it in right.
Vanessa.
Yeah, you have to press
You have to
second.
No, I have been. Leave me alone. I'm not talking about that.
Okay.
Oh, it's a point. Okay, that was my problem. I was not going to get it. I was
Alright.
putting.
Did you guys get it? Let's try last one for today. I don't know if I'll get through A and B, but we'll at least do A. What amount deposited today? If I want the amount today, the amount right now, what variable is that? P. I am looking for P. At 4.8%, so that is R. We always move it back to, it's like dividing out of 100, so 0.048. Compounded annually, so N is 1, will give $15,000. If that's what I'm going to get, what is that? A. In 42 months. What's that? T. So, but time has to be in years, so how would I change 42 months into years? Divide by 12 and we get? So this is my regular compound interest. Plug in what we know. The A is 15,000. I don't know P. R is 0.048. N is 1. 1 times 3.5 power. You are welcome to clean this up a little bit if you want. 1 plus 0.048 divided by 1, which is 1.048. 1 times 3.5 is 3.5. But how am I going to get P by itself? Divide that whole thing over. So what you're typing in your calculator is 15,000 divided by 1.048 to the 3.5 power. when we divide that, our amount today should be less, P is always smaller than A. I get $12,729.95. Is that okay? I think I can do B, and then I promise I'll stop. If only 10,000 is available right now, what would that 10,000 represent? That's key, that's what I have right now. I still want to get my 15,000, so my A is still 15,000. I'm still talking 42 months, so my time is still 3.5. I failed to say N, let's assume the N is still 1. But I'm asking for what annual interest rate is necessary. This time I'm looking for my R. Okay, so we know how to solve exponential equations, so we can solve for different variables. So if I plug this stuff in, how would I move my 10,000 to the other side? Divide it. 15,000 divided by 10,000? What's the opposite of a 3.5 power? Yeah, you can think of it as a root or a 1 over that. Okay, it looks ugly, but we're going to put it all in the calculator anyway. So to get R by itself, you have the 3.5 root of 1.5 minus 1. So we could solve for different variables here. And I got 0.122.